Okay, if we're going to solve this one, the basic algebra would be to add 4 to both sides and divide both sides by 3. So you can take a couple steps to do that if you need to. But that would leave you secant squared equals 4/3. And then to undo a square, you would like to do square root. And if you were having trouble getting the answer, the correct answer for this one, and you got to this point, I have something missing here, and this is a very, very, very common mistake and something that you've got to put real effort into right now, today, clearing up. Otherwise, you're going to miss all these. When you take the square root of both sides, you have to do plus or minus. Think about x squared equals 25. Something real basic. 5 makes this work, but so does -5. And if you just take the square root and you don't do plus or minus, you just lost half your answers. So the same thing applies. When you take the square root of both sides, you need plus or minus. Okay, then you need to be able to deal with square rooting fractions. The square root of 4/3 is the same thing as the square root of 4 over the square root of 3. And the square root of 4 is, of course, 2. Square root of 3 doesn't break down. All right, now I guess I could rationalize this, but it's also what secant equals. And I don't even bother memorizing secant values anyway. So I'm going to take the reciprocal of this side and take the reciprocal of this side. And now it does look familiar. I do memorize spots where cosine is square root of 3 over 2 and negative square root of 3 over 2. So one trip around the unit circle. Sorry, my dog's knocking stuff over back there. One trip around the unit circle. Cosine is positive square root of 3 over 2 here and negative square root of 3 over 2 there. So there's the 4 locations. And so one way to write your answer, let me erase some of this, give us some space here, is I could say this spot, which is pi over 6, plus everything coterminal, because the directions don't say between 0 and 2 pi, so I got to add all the coterminal stuff to it. And this spot, which is 5 pi over 6 plus 2 pi n, all the coterminal angles, 7 pi over 6 plus 2 pi n, should be this spot and all of its coterminals. And this spot, which would be 11 pi over 6 plus anything coterminal to it. Now, there's technically nothing wrong with that. If you write that on an assessment, mathematically that's correct. I would accept all of this as your answer, but that's not how most people are going to do it. And for you to know if your answer is right, like as you check the back of the textbook, you really want to practice condensing this. And condensing this, what I mean is, like, I could have just said, let me start off with pi over 6. So x equals pi over 6. Okay, but then instead of going all the way around 2 pi, which works, what if I had just added 1 pi? Well, that would have hit this location, and I would not have needed to add that as part of my answer. So instead of adding multiples of 2 pi, let me just add multiples of 1 pi, since these are evenly spaced. And then when you add a second pi, you end up getting its coterminal angles. Add third pi, you end up getting its coterminal angles, etc. So since those are evenly spaced out, you could condense those 2 statements I had here to just this one statement there. And it's a lot easier to write. It's pretty tedious to write all 4 of these out. So once you practice it and you can just write it out the first time, it's actually a time saver. So same thing over here. I could have said 5 pi over 6 as an answer. X can be 5 pi over 6. But yes, adding 2 pi in gets all the coterminal angles for that angle. But then I've got this one over here I need to hit, and it's also equally spaced. If I added pi, I would land here. If I added another pi, I land there. Add a third pi, I land here, etc. So I can completely ignore this if instead of adding 2 pi in, I just add 1 pi in. So the best answer, what you want to practice doing and what the back of the textbook is going to do, is just going to make it look like that.